All right, let's finish up complex numbers talking about how to go about dividing them using something called conjugates. All right, for starters, let's go back and think about how to multiply these two complex numbers. We have 6 plus 5i times 6 minus 5i. All right, just like we've been doing, we're going to FOIL these two complex numbers. All right, and again, just like we've been doing, we're going to combine our like terms. Now note here, let me grab my pen again here. This becomes minus 30i, this becomes plus 30i, so they cancel each other out. There is no I term. We simply get 6 squared, which is 36, and we get minus 5i squared, or minus 25i squared. All right, again, just as we've been doing, we're going to substitute I squared for negative 1. It's going to change the sign of the 25, so I end up adding 36 and 25 to get 61. All right. Now, how interesting that we were able to take two complex numbers, multiply them together, and we get a real number. Our answer is 61, the plain old 61 we've always dealt with. There's no imaginary unit. It's just 61. All right, so what's going on here? Take two complex numbers, multiply them together, we get 61. And the biggest key here, guys, is to notice that the only difference between these two complex numbers is the sign of the imaginary part. One complex number has plus 5i, the other one has minus 5i, right? That makes them complex conjugates. All right, and this is going to happen anytime we multiply two complex conjugates. We'll always get a real number. All right, so on that note, let's try to find the quotient here. And you know, it's a benefit to you to be listening to this lecture because I'll give you a little hint. When we divide complex numbers, maybe it's better to think of it as getting rid of the complex number on the denominator, rather than thinking, how in the heck am I going to divide 5 minus I into 3 plus 2i? Don't think of it like that. When in the homework and quiz and on the exam, when I say find the quotient, what I'm asking you to do is multiply everything, the denominator and the numerator, by the complex conjugate. So here, the complex conjugate of the denominator is 5 plus I. So note, I'm going to multiply the top and the bottom by 5 plus I. Right? Again, just like I've been doing with multiplication of complex numbers, I'm going to FOIL the top and the bottom. Okay? And when I FOIL the top and the bottom, it's just a matter now of combining my like terms, substituting I squared for negative 1. All right, so we can see that the 3i plus 10i becomes the plus 13i. All right, our I squareds become negative 1. And I look like I have my final answer. All right, I combine the top, I combine the bottom, and I have 13 plus 13i over 26. Is this your final answer? Well, most likely when a math teacher asks you that, the answer is no. And what we can do here is, rather than looking at it as one fraction, let's write it as two fractions. And again, when you do this, it's amazing visually how your eyes say, whoa, I think I can reduce 13 over 26. And we can reduce 13 over 26 either by using our calculator or by taking out a 13 from top and bottom. And you can see our final answer here in simplified form is 1/2 plus 1/2 I. And it's important to note that when the instructions say write your answer in standard form, this is standard form. It is reduced and it's in the form A, our real part, plus BI, our imaginary part. All right, let's do one more. This one usually throws students for a loop because it's just 3 over I. What could possibly be the conjugate of just an I? Well, let's go back to the definition. All right, remember it's opposite sign of the imaginary part. So if our denominator is positive I, what do you think our complex conjugate's going to be? Exactly, negative I. All right, so I'm multiplying the top and the bottom by negative I. All right, and in the numerator, I end up with negative 3i, and then in the denominator, I get negative I squared. All right, again, substituting -1 for I squared, I end up with -1, or just 1. Pay attention there to how those negatives work. All right, and so in the end, my answer is -3i over 1, or simply -3i. Okay, and again, rather than thinking of this as dividing complex numbers, you're going to be much more successful thinking of it as getting rid of the complex number in the denominator. Right? And so you're done when the final answer has no complex number in the denominator. All right, just to sum up here before exam 1, what am I expecting you to be able to do? Add and subtract and multiply complex numbers. Find the conjugate of a complex number. Divide complex numbers. Add, subtract, and multiply negative radicands, and write negative radicands in standard form. That is pretty much everything I've gone through. If you have any questions, definitely, as always, let me know or ask on social media. And next series is going to be on quadratic equations.